let's have a go at a second derivative question now, where we're not using cubics and quartics because they're a little bit more predictable, but one with 2x times e to the x is going to look a little bit more interesting. Okay, now just for the purposes of this video, I'm going to give you a basic idea of what the graph looks like. Okay, it's going to look something like this, where we have concave down to the left and then concave up to the right. Okay? Now, let's have a look at the first derivative. It is a linear times by an exponential function, so we're going to have to use the product rule. Now, I use the product rule like this. You've probably learned it slightly differently, but it's okay. It'll still work. So I'm going to call this one u and this one v. V is e to the x, and u dash is going to be 2. U is 2x, and v dash is going to be the derivative of e to the x, which is just e to the x. Let's tidy that a little bit, and we get 2e to the x plus 2x e to the x. All right, that was the first derivative. The second derivative is going to be 2e to the x, and then I have to derive 2x e to the x, which is exactly the same as this here. So I already know what the derivative of this is. I wrote it just there. So it is 2e to the x plus 2x e to the x. Okay, now let's find the point of inflection, and there is only one, and we do that by making this function equal to 0. So we have 2e to the x plus 2e to the x plus 2x e to the x and equal to 0. Now I've just noticed that they are in fact the same. They're the same, so I can simplify that and turn that into 4e to the x. All right, and since I have e to the x in both terms, I can factorize e to the x. I can also factorize a 2. And 2e to the x times 2 will make that 4. And 2e to the x times x will make 2x e to the x. Make that equal to 0. All right. And the null factor law says this is equal to 0 or this is equal to 0. And so I'll write that. Either 2e to the x is equal to 0 or 2 plus x is equal to 0. And here, I hope you've realized that there is no solution here. There's no possible value for x that makes the left side equal to 0. And the graph of e to the x looks like this. The 2 only increases the amplitude, increases the vertical shift, so there is no value where it touches y equals 0. This is a no solution. And over here we have one solution, and that's what we were looking for. So the point of inflection, which is right here, happens at -2. Right. Now let's have a look at the concavity. Choose a value to the left of -2, like -3, and we're expecting the second derivative to come out to be negative 4e to the -3 plus 2 times -3 times e to the -3 is, that it simplifies to be 4 over e to the power 3, take away 6 over e to the power 3, and 4 take away 6 is negative 2e to the power negative 3. And that's obviously negative. It's less than 0. Therefore, concave down. And that is correct. That's what we were looking for. And lastly, we're going to choose a value to the right of the negative 2. You could pick negative 1. I'm going to pick 0 because 0 is always a nice one to choose. So when we substitute 0 for x, we get 4e to the power 0 plus 2 times 0e to the power 0. And this is the same as 4 times 1 plus 2 times 1 times 1, which is 6. 6 is obviously positive, and therefore it is concave up. And there you have it, concave up. All right, good luck with those questions.